All right, so today we are continuing with multiplication of polynomials, and we're just looking at the part 2 of multiplication of polynomials. We're looking at larger polynomials. So, for example, when we multiply a binomial or greater by a trinomial or greater, we're going to use these two methods. So there's one method, it's called the horizontal method. It's the one that you're familiar with when we did the FOIL method. So basically, we're going to take each term from this first factor here, 3x plus 4, and we're going to multiply it to each of the terms in this second bracket. So I'll show that as a step. Let's just write that out. So basically, we're taking 3x plus 4, and we're going to multiply it by 2x squared minus 3x plus 5. All right, so you can do this with arrows. I'll just show that with arrows in a different color. So you're taking that 3x and you have to multiply it to the 2x squared. You have to take the 3x, multiply it to the negative 3x, and the 3x is going to multiply the positive 5. And then you're going to take the 4, the second term here, and multiply to each of those as well, like that. All right, and you can show that as a step as well. So we'll just show that I'm taking my 3x, that's covered here, but 3x, and I'm going to be multiplying it by all of this, so we can basically use distributive property. And I'm taking that positive 4, and I'll be multiplying it to all of this. Some students can just get away with just doing the arrows, and they don't necessarily need to show this step, but showing a step and having all your steps organized, it is very important. So let's take the 3x, we're going to multiply it to each of those. That's distributive property. So 3x times 2x squared, that's 6x cubed. All right, 3 times 2 gives me the 6. X times x squared gives me x cubed, or x to the power of 3. 3x times negative 3x, that's going to be negative 9x squared. The 3x times 5 is positive 15x. All right, next we're taking this positive 4, multiplying it to everything inside the bracket. So we have a positive 8x squared, then 4 times negative 3x gives me negative 12x, and then 4 times positive 5, which is positive 20. All right, so here we have this really long expression. The last step is to collect any like terms. All right, so we have a 6x cubed here, no other x cubeds. Then we have a negative 9x squared and the positive 8x squared. We have 15x and negative 12x, and then we just have the positive 20. So rewriting this now, we have 6x cubed, and then negative 9 plus 8, that's negative 1, or just a negative x squared. Then we have 15x minus 12x, which gives me positive 3x, and then just plus 20. All right, and I did write this in descending order, so x cubed, x squared, x, and then just the constant. All right, so that was done using the horizontal method. The next method, it's the same example as previous, but we'll just use this other method, the vertical method. But like I said, the horizontal method is usually the preferred method. So it's similar as if you were multiplying numbers, except you're going to start at the front instead of the back. So you'll be multiplying here, the 3x here, instead of the 4 first. All right, so 3x will be the first multiplier, and then the positive 4 would be afterwards, and then you're going to add like terms. So if you're doing this method, you take the 3x and the 5, 3x times 5, and you get the 15x. And then you have 3x times negative 3x, that gives you the negative 9x, and you do have to add your positives and negatives. And then we have 3x times 2x squared, which is 6x cubed. All right, then we're going to multiply our second term here, the 4. So 5 times 4 is positive 20. And then 4 times negative 3x, which is negative 12x. So notice how I'm putting like terms under each other. I forgot to put the squared here. So just remember this was the 3x times negative 3x, which was 9x squared, negative 9x squared. Okay, so next we have the 4 times the 2x squared, which gives me a positive 8x squared. All right, so then after that, we're just going to add. All right, so we just have the positive 20 here. 15 minus 12, which is a positive 3x. Negative 9 plus 8, which is the negative 1x squared. And then we just have the 6x cubed. All right, so same answer as before. It's just done using this vertical method. So just to show again, it was the same answer. Okay, so we're just working on this example here, and I'm just going to show this using arrows. So we have to take this x squared, we have to multiply it to the 2x, we have to take the x squared, and we have to multiply it to the 3. Then we have to take the 4x, multiply it to the 2x, multiply it to the 3, and then we have to take the 7 here, multiply it to the 2x, and multiply it to the 3. All right, so lots of arrows there. So when we take x squared and multiply it by 2x, we end up with 2x cubed. Then we take the x squared, multiply it by the 3, we end up with positive 3x squared. Next, we're going to take the 4x, multiply it by 2x. That gives me a positive 8x squared. And then the 4x times 3, that gives me a positive 12x. Next is the 7. 7 times 2x, that gives me a positive 14x. And then we have the 7 times 3, which is positive 21. All right, now you're going to go ahead and collect any like terms. So 2x cubed, there's no other x cubed. We have a 3x squared, we have an 8x squared. Those two will collect together. Then we have a 12x and a 14x that will collect together. All right, so we end up with 2x cubed, 3x squared plus 8x squared, which gives me a positive 11x squared. And then 12x plus 14x, which is positive 26x. And then we have plus 21. All right, and that is the final answer for that one. All right, so here's another example that we just worked on. So the 7y has to multiply to the 2y squared, it has to multiply to the 3y, and it has to multiply the negative 5. And then we have the negative 3 that has to multiply to the 2y squared, to the 3y, and the negative 5. All right, so let's begin. So 7y times 2y squared, that gives me 14y cubed. Then I have 7y times positive 3y, which is positive 21y squared. 7y times negative 5, which is negative 35y. Then the negative 3 multiplied by 2y squared, which is negative 6y squared. Negative 3 times positive 3y, which is negative 9y. Negative 3 times negative 5, which is positive 15. All right, and now we get to collect our like terms. 14y cubed, there's no other like term for that one. We have 21y squared, and we have a negative 6y squared. And then we have the negative 35y, and the negative 9y that we can collect together. All right, so 21 minus 6 gives me a positive 15y squared. Then I have a negative 35 minus 9. Okay, so recall it's negative 35 minus 9, which is the same thing as negative 35 plus negative 9. All right, either way you enter it in your calculator, you'll get a negative 44y. And then we just have the positive 15. All right, so the last example here, we have questions that have 3 binomials. So we would work with 2 of them first and then multiply the last one afterwards. All right, so here x times x would be x squared, x times negative 6, that's negative 6x, negative 5 times x, negative 5x, and then we have negative 5 times negative 6, which is positive 30. All right, and then all of that is multiplied by x plus 3. And here you can collect those 2 terms together. So we end up with x squared, and then we have negative 6 minus 5, which is negative 11. And then we have plus 30, and then you'd multiply that to x plus 3. Okay, so x squared times x, which is x cubed, x squared times the 3, which is positive 3x squared, and then we have the negative 11x times x, which is negative 11x squared, negative 11x times the 3, which is negative 33x, then 30 times x, which is positive 30x, and then 30 times 3, which is positive 90. All right, and then you would collect your like terms. So we'd collect this one, and we'd collect this one and this one together. So we end up with x cubed, and then we have 3 minus 11, which is negative 8 x squared, then negative 33 plus 30, which is negative 3x, and then plus 90. So it's just an extra step. You'd have to multiply the 2 binomials first. You'd end up with your trinomial, and then you'd multiply it with the binomial.